Hey everyone, I'm Lucian Freemesser,
I'm Highland Sherman.
and today we're going to be doing a bit more of an advanced CAD tutorial on SolidWorks and then doing some assemblies inside of SolidWorks. So I guess we'll just get started. This is SolidWorks. If you haven't seen it already, it's a bit different from the Autodesk Inventor and all the other Autodesk products. So we're just going to be going through some of the basic things you can do on SolidWorks. So if you might see a big box with like a part, an assembly, and a drawing. So we're going to create a part to start. But if you don't see that, you can also just go up File, New, and then click on the part here. And once it loads in, this is basically what you have to work with when you're designing things in SolidWorks. You have your tree over here with your design tree, which will fill up as you do things to the part. If you do an extrusion or a sketch, it'll show up there. And then you'll be able to click on it and edit those individually as well. Up above, you have kind of all your tools that you can use, and for the most part, you only need to worry about like the features and sketch toolbars. The rest is kind of like things you might do afterwards. So like a flow simulation is like aerodynamics, stuff like that. But so for now, just worry about these two, and you can kind of go through and look at them, see how they're a bit different from, the Desk Inventor. But for the most part, the basic ideas are the same. You have your lines, you have your circles, you have your rectangles, and so forth. And then you have like a smart dimension. That's basically the same as a dimension in Inventor. And then for features, you have like extrudes, revolves, and the rest of these are like sweeps, lofts, bases. All that sort of stuff is pretty much the same. So the first thing you're going to want to do when you create a new part, if you don't have your default settings set to this, you want to go to your options, and you're going to change the units of this. So you go to the document properties, units, and then we like to work in millimeters. So you're going to select the MMGS, which is millimeters, grams, and seconds. And millimeters are just a bit more precise, easier to work with, and more things are measured in millimeters and metric, so we tend to use those. But if you go down to dual dimension length and click on where it says millimeters here, you can actually change that to inches. So then you can work in both millimeters and inches. And we'll change this to 3 decimal places, just because inches are not quite as precise, so we like to have a few more decimal places just to make sure we're getting it accurate. Then, so you can like effectively work with these dual dimensions, if you go up to dimensions here and then click dual dimensions display, that'll allow you to see both millimeters and inches when you're designing, and so you can just use those effectively. Then just click OK, and you're good to start your part. So today, to start, we're going to be kind of creating this part. It's kind of just an arbitrary part just to get started. Good one to learn on. Does a few different things. And to start this part, I would be kind of looking at like the slice of it here and trying to do a revolve around a center axis to create the circular shape of it to start. So we'll kind of create like a stair-step thing here first in SolidWorks. So go back to SolidWorks, click on the sketch thing, and it'll ask you which plane you want to do the sketch in. And this is very similar to Inventor, but you're just going to click on the front plane, and then you can start your sketch. So I want to revolve around like a center line or something. So if you go up and click line, one of the drop downs is a center line, and that's basically like a construction line in Inventor, but it just allows you to make a line without like really including it in the part. And you'll just do a vertical line, kind of arbitrary length, doesn't really matter. And then you can just do a regular line off of that, and we can stair step down like the part kind of looked like. You're going to want to make sure all those angles are 90 degrees. It'll kind of snap to those places, but if they're not, you can easily constrain them later by clicking on the 2 lines. So click one, hold shift, and click the other. And then you can see there's all these relations on the left, and you can click perpendicular if that's what you want, and then they'll stay there, perpendicular. So first, I want to go back and check, what's the dimension away from the middle. And the total diameter of the inside hole is 22 millimeters, so I'm going to want to make that 11 millimeters away from this line. So use the smart dimension, and under the dimension drop-down, there's all sorts of different dimensions, but basically the smart dimension just picks whatever it thinks is the best one for you, and for the most part, you can just stick with that. And so I'll type in 11 millimeter. hit enter, and now it's 11 millimeters away. So when I revolve it, I'll have an inner diameter of 22 millimeters. If I go back and look, I can see that there's some other dimensions here concerning the heights and widths of these. And so I'll go through, and you also might need to use these as well. You can go through and dimension all of these as well. So I'll do that now. This one's 5.5 millimeters, and this last one is 3 millimeters. Then we can start constraining the widths of these. So if I know the inner diameter is 22 millimeters, and then the diameter of the top circle is going to be 14 millimeters, so I can just add 3 millimeters here. And then this one's going to be 17 millimeters, so I can just do 3 again here. And then the outer diameter is going to be 22.5. And this one's a bit harder, so maybe I'll constrain this back to this so I don't have to do my addition. And there you go. That's basically the general idea of your revolve. It should look pretty similar to this part right here. And so we'll first go, you can exit the sketch on the right here. And then if you go back to features, you're going to have some more options. And we're going to do revolved, boss, or base. And we'll click on that, and it already knows what you want to do. There's only one sketch and one line, so it'll just basically preview. We want to go 360 degrees around, so I'll click OK, the check mark. And there you go. So you have most of the part, but if you go back and look, there is some some holes that you need to add on the outside. So we can go back and add another sketch to do an extrusion for that. So this time, if you click on sketch, it might not pull up your planes as much. So you can go back to the tree and select top plane. That's what we'll be using. Or you can also click if you want it on a face here. So if I click here, it'll now start the sketch on this face. And that's essentially going to be the same as the top plane since we were revolving around that. So to start, you can convert entities. This is like your project in Inventor, but this will make these included into the new sketch from a different part or sketch. And then I'm going to add a circle from the center of this at a radius of 26 millimeters. And so I'll dimension that. And this is where I'm going to be putting some circles on to make the spaces for those holes. Oh, sorry, radius of 26. So 26 times 2 is 52 millimeters. There we go. And we're just going to add a circle on here. And this circle is going to have a radius of 6. And then you can trim this so it kind of matches the shape here. And we'll just kind of leave that for now. But then you can add a circle on the inside to create your hole. And the hole, if you go back to the image, the whole outer diameter, which we just did, was a radius of 6, and the inside hole has a radius of 2.5. So we can go back to SolidWorks and make sure we got those dimensions right. So 2.5, that means the diameter is 5. And then we should be able to trim this here, here, and here. So now it's all part of that same part. And then we can do a circular sketch pattern if we want for this part and this part. And you can see it actually already came up with 4 instances, but that's basically how many you want around the circle. So you could either do it by degrees, I want them every 10 degrees, or just put, you want 4 spaced out equally around the circle, which is what we want if we look back to our drawing. So just click OK with that, and then we can go trim the rest of these just to make sure that it's all okay when we extrude it, and it's all, we can just extrude it in one part. There we go. That looks about right. If you go back to the image, looks pretty similar to this. And so we can click check here, exit the sketch, and then we can go back to our features tab here and use the extruded boss base. So we'll click on this part. It didn't automatically select it. And then there's a few things we can do. If you notice, it's going down right now. So you can swap the direction on the left where it says direction 1 and it says blind, but to the left of that there's like a reverse direction button. So if you switch that, you can see it goes up. And right now it's only going 10 millimeters up. But if you look back to our drawing, it looks to be equal with the other faces here. And so what you're going to want to do is you could, remember that this was 3 millimeters high, or instead of doing blind, you could do up to surface. Click on the surface, and then it makes it the same level as that. So you can click check there. Looks good. And then the last few things to do are just kind of clean up the part with filleting. So if you notice, these corners are kind of sharp. You can't really machine that unless you do a water jet. And so to make that so it's easier to manufacture the part, if you click fillet up here on the features, then you can click these lines in here, and you can do this all the way around on these corners. And if you accidentally select something, you can just go on the left where it says like face there. I know I didn't want the face. Go back and just hit delete when you select that, and it'll make it easier so you don't have to redo the whole fillet. So there we go. There's all the fillets in there. Those have a radius currently of 10 millimeters. And if you look back to our drawing, I believe it's at a radius of 7 millimeters for those. So we can just change this really easily to 7 down here. Hit check or OK. And there you go. That's basically the part. And then if you wanted to add some fillets, you could add some here. You don't need quite so big, maybe 2 millimeters. There you go. That's pretty much the part. So that's how you would do a basic design work in SolidWorks, transitioning from Inventor, and that gets you through most of the things. There are some other tools, and you can just feel free to mess around with them. Most of them have pretty much the same ideas as Inventor. So now I'll hand it off to Highland to talk about assemblies.
Alrighty, so once you've made a couple different parts with SolidWorks, hopefully you'll get to do some assemblies where you get to put all those parts together to create a larger piece, or for example, in our case, suspension or wheel or whatnot. So I'm going to be showing you guys a model that we put together not too long ago. But it was the rear suspension. You kind of see it here. We have the motor here, we have the wheel, the tire on top, and then this whole assembly here. This is an interesting design because we wanted to make this as light as possible. Our previous year's suspension was quite heavy, and so we've done it out of an assembly this year with tubes, gussets, and then a big insert at the top for our motor. So I'm going to be taking you through the assembly process of this. Making these parts are pretty simple. As you may imagine, looking at what Lucian just did, this tube, for example, would just be the sketch on the end, extruded a certain amount of distance. This tube here would be a sketch on the end, same thing, extrude a certain amount of distance. This part, a little more difficult to make, but if you guys want to give it a go yourselves, I'd be happy to send you the parts and have you try it. But for today's purposes, we're just going to try to make this again, and I'm going to talk a little bit about GrabCAD, which is the software that we use to share all these files so each of us can access them and edit them and essentially collaborate. So to get started, I'm going to start a new sketch, or not a new sketch, a new part like Lucian had. So I'm going to close out of this here, and we are going to make a new one. So instead of going to part like Lucian did earlier, we're going to do an assembly. Click OK. You're going to notice there's a couple different things up here. We have assembly, which is a new tab, layout, which is a little different than the one you saw previously, and then sketch, quite similar with a few extra tools here. But for our purposes, we're going to just start assembling parts. So down here you can see begin assembly. It's going to prompt you to import parts. So what we're going to do is you're going to press browse. Now, before I do this, I want to show you guys GrabCAD. GrabCAD is a software that allows us to make updates, essentially, to to the local web and file system that we have that's shared between all of our users. You can see 29 people are on this, and whenever you make an edit to a part, as you can see on the files ready to upload, inside the GrabCAD folder, which is essentially just another file folder that you have on your desktop, when you add things to that, it'll ask you to upload every time you save something. And so what'll happen is you press upload, upload selected. These are going to be all the changes that you've made to the parts. So you can kind of see here we made a change to the brake bracket, and looks like we deleted the rear motor arm assembly static. So all of these are simulations that we ran previously that we no longer want and have removed from the folder. And so once you make all these edits, you'll be allowed to upload the part. And then if other people make changes, it's similar, but you have to press the other side, which is download, so that you also get the updates that they made. Now everyone, when someone makes a change, everyone, when they upload and download, respectively, they will be able to access the same parts from everywhere. And so this is something that we'll have everyone get on when you join the team or decide you want to work on CAD. And it's a great tool. But this is also where we save all the parts. So GrabCAD folder on my computer, it's called GrabCAD, CAD 2019-2022, and from there on you can navigate. But when I call in these parts here, we can go into GrabCAD 2019-2022 and click on 2022-2023 because this is the year that we're working with. And so all these parts in here, Lucia and I have been working on for the last couple of weeks. And we can navigate to this rear tube suspension, as I talked about earlier. And you see there's a folder called parts. And so these are all the things that you're going to need to put our assembly together. So let's start with just importing some simple things. Let's go torque tube, which is essentially that tube you saw earlier. We're going to go assemble, insert component. The next part, we're going to go, why not put our brake bracket plate. So we need two of these, remember. So you can also just Control C, Control V. Now there's two of them. You can move them out. And we can insert more. We need two of these hinges. I'll just Control C, Control V that too. Take another one. We need the rear tube, which is the shorter version of the long one. Then last but not least, we need the cap insert. And so once you have all your parts here, you can see some of the work we've done on this. This cap insert we've lightened up because we want the suspension to be as light as possible. But as for the as for the actual assembly without the motor, these are all the parts you'll need. So we're going to start using something called mate, which is how you attach parts to another in an assembly. And so as we all know, this is the back. So let's start with putting the hinges on. So you can take this face and you can assemble it or adhere it to this face, and you can see they're going to go one-to-one. However, with most constraints, you're going to need more than one to make them work, because as you can see, with just a face-to-face constraint, the CAD software doesn't know where the constraint is. All it knows is those faces have to be tangential. And so to fix that, what we'll do is we'll press mate, and we can take this corner, or this edge for example, and then constrain it to this edge. So now if you'll notice, we can also move up and down currently, not left and right, and they'll still stay tangential, which means we need one more constraint to do the top. So we're going to go this edge to this edge. Simple enough. Now if you notice, when I move these around, nothing can go. So we'll do the same thing with the other side. Take this edge, take it to this one, confirm, and then the same thing with the top. And something I wanted to note really quickly, because I just remembered this, movement as I move around. If you press the middle mouse button, it allows you to rotate. If you press Control middle mouse button, you can drag and pan. And if you want to zoom in and out, it's just the scroll wheel. And so that's how I'm navigating around these objects and kind of getting the right angle on these constraints. So with that said, let's start constraining these together. So this is the long one, so we're going to take that there. And then we're going to take the top edge here. So you can see it's starting to come together a little bit, starting to take that shape that we saw earlier. But now we need to put these gussets on. And again, similar process. Except we're going to do a plane to plane here. So we're going to go plane to plane like that. And then we're also going to go plane to plane over here. Because we need to rotate this part around. Sometimes the CAD software has a hard time identifying that, as you can see here. And so what I normally do when it gets kind of stuck like this, because obviously it's facing the wrong direction, as you can see here, it's not wanting to go in the correct spot. So what I normally do is I will actually delete the part on both, and I will insert the component again. So we'll grab the, where'd it go, break bracket plate. And as you can see, it's not in the right dimension here, but what you can do is you can actually rotate them when you import them. So if you look, the y-axis is vertical right now, so we want to revolve around the y-axis. And there it goes, it's perfect. So I'm just going to Control-C, Control-V that one again. Move that out here. Now when I do these constraints, it should be perfect. It'll just move right to the right spot. We'll go plane to plane here. And so this piece can't move. Actually, it can. Sorry, I didn't do a plane to plane down here. Let me do that here. It's plane to plane. Now this will move with the whole part. Can't move. So do the same thing on the other side because we want this part to be strong. Part's only as strong as its weakest point, so it's pretty important that we put a gusset on both sides. Once we get this locked in place here, both sides are good. So everything is connected, non-moving, grounded. All it's left to do is just insert this piece. So this is also quite simple. We're going to do a tangential constraint because we know the outside diameter of this tube matches the inside diameter of this tube. Having a surface-to-surface constraint will work for our purposes and allow us to move it. So as you can see right now, it's going in and out of the tube, but we want to stop right at this joint here. We are going to mate it right on this edge. Oops, click the wrong thing. Click on this edge. Click on this edge. Voila. Done. So there's your simple sort of suspension piece. If you want, we can also put in the shock holder, which is, where's the shock bracket? Here, brake bracket. I actually just realized I misnamed this. This should be called shock bracket. You can fix that in a minute. I'm going to rotate that to the right orientation. Mate. I'm going to take this edge. This edge. Actually, just a point to point. I wonder if it's going to mess it up. Yeah, I'll go edge to edge. Beautiful. And then we're going to go surface to surface here. Beautiful. So that's your part. If you want to put the wheels on, it's going to be a very similar process. The motor has a bolt pattern, a 6-bolt pattern that goes here. All you need to do is constrain one of the holes here, one of the holes here, and then on top of that, the wheel and the tire concentric. And those are similar mates as long as you have the part and the holes match up, which is something that's very important when you're working on assemblies. If you want things to fit together correctly, you need the bolt patterns to line up, you need the edges to line up. Something that you can constrain together geometrically that won't break the part. And so I'm actually going to leave it just here because everything else, if you have any questions, you feel free to come up to us and ask us. But this is essentially how you could put an assembly together in the basics of how that all works. One more thing that I'm going to try to show you here is even in assembly you can create sketches. So for example, if I wanted to know the distance between this hole and this hole, there's 2 ways I could go about that. I could use the evaluate measure tool. Sometimes this is a little finicky though, so I could try to take that hole, and you can see here to give me a couple different values. It'll give me the dimensions in all of the axes. So here it's going to give me the vertical distance, which is what I want, 14.75. It'll also give me the area of that hole. It'll give me the diameter, the perimeter. It's going to try to measure basically everything that we have. The other way you could go about this is you could create a sketch. Oh, not smart dimension. Sketch on this face. and you could actually just draw a line on a 2D surface between the 2 points, and then you can use Smart Dimension 14.75. But unlike in a part, you can't extrude if you make a rectangle. You could make a new part inside of an assembly. However, you can make edits to these parts individually if you use things such as Hole Wizard or things like that. That's a little complicated for now, but I would try to put this together once you all get on the GrabCAD. I'll have you all try to put this assembly together, or if you feel like working on a specific part, we can also do that. But this is where we're going to leave it off today. So thank you so much